Hi guys, I got 4 batteries, broken batteries, various damages on them. I'm gonna open them up and see how can I sort out. I got 3 DeWalt ones and 1 Makita one. If I can get 75% or even 50% repair on them, say half, I'll be happy. So we're gonna start on say Makita first, and then we'll do DeWalt ones and see how it goes. If you like it, thumbs up. If you don't thumbs up. Don't have to put thumbs down, just don't thumbs up it. If you like, subscribe for more, please do. You're more than welcome to watch the other videos. Now I'm gonna do this uncut, so you can actually see all the little struggles and what goes into opening the batteries, finding the fault and repairing them. So I'm not going to try to skip various things and just make a pretty little video. This is going to be a proper uncut video on taking the batteries apart, and I can guarantee to you, you'll see there will be different damages on all 4 of them. So you will see different ways of repair, different damage and how to diagnose them. So again, it's quite simple. I've done them before, done these batteries before. It's quite simple, quite straightforward. Anyone with half common sense can do it. Please have a look and make judgment for yourself as well. Thank you. Copy Makita is just dead, doesn't do anything. I mean, contacts look okay from outside, and I believe it would be maybe thermocoupling inside that is gone, or something got unsoldered, or say solder or wire broke. That's most common thing. Now this DeWalt one, well, let me just see on this one. I would say again similar to Makita, it's completely dead. It's either thermocoupling gone or something got unsoldered or broken wire. This one, oh yes, this one, the contacts, especially this left hand side one here, it's folded in, so it doesn't really achieve good contact. The battery inside, it actually works. It can't charge because when you put in a charger, it doesn't achieve contact. So we got that one to sort. And this one, it's working, got good contacts, but it's mashed up here. It has fallen with a drill. You can see it's all cracked up and broken. So Makita one will probably need a bit of soldering or something inside. We'll have a look. And what I got here, delivered off internet, an ordered casing for DeWalt batteries. It's supposed to come with contacts, so we'll have a look. So it's got the whole cradle for the cells as well. It's got a button, yeah, it's got contacts. Got a lot of screws and actually plates. If you want to put a new battery cells in, you can actually solder it on one. We're not going to need that. We're going to use genuine existing ones, so we're not going to need this part either. So let's put this aside and let's do Makita one first. So we got 4 screws on the back. That will be Star or Torx T10. I mean, it's not genuine Makita one. It's just one of the copies. It says 6 amp, but we'll be happy if it's 2.5. So last screw. check connections underneath this plate. That feels a bit unsecure. Nothing detached. Okay, so this one is not as obvious as I hoped. This will be thermocoupling, we'll have to check on that. 85 Celsius. So if that's the case, we'll have to either get another one or try to bypass it. So that will go from there, from point B, which is positive, and then to this point here, which showed us thermocoupling link. So we may just shorten that and then have a look. Okay, that will go a bit more. It will need a bit more attention. Let me just try to pull. The thing out. They stuck them down to the bottom, so okay, I'll leave it for now, and just a bit of just trying to see for any obvious defects. Okay, I'll get a multimeter on it and do a test. So with a bit of zoom, this battery has not been in use for quite a long time, so we're going to just test the voltage and continuity. So this is the ohm meter now, on ohm meter selection. Just put that there. Check continuity of the thermocoupling, which is between these two contacts here. So thermocoupling is closed, which is good. I'm going to change it to 20 volts DC. Let's do the main battery terminal contacts. Sort of. Right, so if I go down past there on the battery there, and on end of the battery here it's showing 16.25 volts. If I'm going the contact there and there on the plates, aha, now it's showing. Earlier didn't show anything. So we got battery minus, battery plus. Now it's showing it on. I would say that these contacts just not been secured. Now it works. It was odd because this battery was dead as anything. Now showing 16.26. That's quite solid. So it must have been just a bit of dirt or something on the contacts there. it works now, then it's been successful. All it needed, whoops, pardon, all it needed is just a bit of wriggle jiggle on the contacts. So right, let's try again. Yep, she's on. Right, let's try. So we got this blower. It just had a little bit, and then it stopped. Right. Let's do another test like this. .5 should give a little bit more. Try to put it on a charger. Okay, leave it to charge and then we'll try it again. Whilst that is getting showing charged. Right. Right, so the reading is 16 point something volts, should be at least 18. Plug it into the charger and it shows fully charged, and then when I plug it into the tool it doesn't want to run the tool. I would imagine one of the battery cells is dodgy, so I'm gonna take off the red and black wire off, and then take this cradle off, and then we'll gonna take the cells out and inspect it all and see. And can lift it off now, but it's attached here and there, and also this little wire on the back. So let's unsolder these two. I just plugged my soldering iron on. I think iron got hot enough. Just want to heat it up. Yep. One side done. negative terminal off. Yeah. There's a bit of damage on the paint on this cell. That might be a dodgy one. It's been stuck with double-sided tape down the bottom. I'll have to try to prise it up carefully. Let me see if I can actually reach these top ones. Might be able to do it. Check voltage. So I'm not going to worry about polarity now at the moment. I'm just going to use them like that. 389, 390, 391, 0.5. 389. So that one is damaged. That could be a reason. See, damage there. Right, I'm going to try to get them all out. See what can we do with it. Right, so the screwdriver, try to get behind the tape insulating part. Right, done it in the way. I don't want people to take this apart. Right. That's a double-sided tape it was stuck down with. Now we can test all the cells. So far we know that that one was damaged. Let's check the bottom. 390, 391, 393. So both of these so they're done in like a cell blocks. It's like 2, 2, 2, and 2, and 2. Yeah. So this cell block here is showing half a volt. Now the question is it both of them or only one? That's the question. It doesn't matter much because I haven't got spare at the moment anyway to try it. Now I don't have a spare cell, so I got two options. I either try to get a spare cell to order it online, or to leave this battery for spare parts, because I got good contacts, I got good thermocoupler, and I got some other cells that are good. Now pulse is open. Let's just do a little checkup and read out. It says 2000 milliamp hours, 3.7 volts. 2000 milliamp hours, that's 2 amps at 3.7 volts each cell. Now you can see it's 1, 2, 3, 4, 5 set of doubles. The way how it's been wired up, it would double the amperage. So if it's 2 amps per one row, it will be 4 amps together, and 3.7 times 5 would give you 18.5 volts. So the voltage is done that way, and amperage is done this way across, because you got one in series and one in parallel amperage in series voltage. So they claim that is 6 amp. It's not, it's only 4 amp. So my expectation was to be at least 2.5 amp altogether, but actually being 4 amp, it's not bad, because it's still cheaper, way cheaper than genuine ones that also blow up like that every now and again. So this battery, it had some heavy use, and I'm not surprised that the cell actually blew up. So I think at the moment I'll just leave it aside and see if I can get some spare cells, maybe from some other batteries, try to salvage, or if I'm going to buy a couple of new cells. So DeWalt batteries, first one I'm going to do is going to be one with smashed up casing. So on this battery everything is fine apart from the casing, and to be honest with you, it's the top part of the casing only. So I would say it will be T10H, one with a hole, like a security screw. No, it will be probably smaller than that. This one is T10H. Oh, sorry, this one was T15, so this one is T10H. Yep, T10H. Little Torx with a hole. Different construction than Makita. Here's longer screws, with the head more exposed to the surface, not so sunk in. So we can actually open it up. It's like a common bit rather than have long shaft. Special screws. Right, it's turning around because it's fixed to the smashed up side of the battery. A bit careful, right. Oh. Right, when we talk about quality of batteries, this one, yes, it's mashed up, and it was fairly new. I think I only had it a couple of months, and the thermocouple burned out on it. So what I did, a bit of redneck repair there, I actually soldered a piece of wire across 2 contacts to keep it together. So you can see a bit of corrosion there, but apart from that, everything else still good. So I'm going to replace the top bit, the lid. So genuine one has got yellow lid with a black button. Non-genuine one has got opposite. Let's see if it's gonna interchange nicely, or do I have to replace the bottom part as well, which would be a bit of pain. No, it's not it's not going in as I wanted it. Just double check. And apart from these holding fins, I mean obviously genuine one, it's thicker gauge plastic, it's a bit heavier, and it's got more of these ribs and fins that are giving more stability to the casing. So I'll just have to try gently again. Yes. Okay. Just to say, this one was already repaired once when the thermocouple went, and I just done a quick redneck style repair by shortening that, and I'm running risk of maybe catching fire on it or something, but it's been in use for the last couple of years like that, and it was fine. So fingers crossed, I'll be alright. Right, one battery repaired. I can try all the drills here. Yeah, it works. So one repaired, two more to go. Right, the next one will be, let's do one that has got no sign of life. Yeah. So, probably thermocoupling. I mean, to be honest with you, if that thermocoupling has broke, I can get the one from Makita, from that fake Makita, and put that one in. So let's see. Yay! There you go. Oh, it's got actually strong burning smell. There you go, it's a thermocoupling. It's burned out. It's a little spring. It actually burned a bit of plastic there as well. So what should I do? It's like a little fuse. I could get that one from Makita. I took apart earlier. Yeah, I think I'll do that. Because this one already, it's probably unlikely I'm gonna buy new cells for it. So let's use that thermocoupling on this battery so I can have this DeWalt one fully functional. Now how that happens usually is if you overforce the battery. Say for example, if you have a bit of like blunt saw blade and you push it a bit harder when you're ripping or something, or if you've got like a little, like a grinder, small disc cutter, 4.5 inch, and you try to cut some tiles a bit quicker than what you should do, and the revs drop, and as the revs drop, power consumption goes up, and that can roast the battery. Now very often that is what happens, that safety thermocoupling gives up and battery doesn't catch fire. Otherwise, as I said, in one of the other batteries I actually soldered across and I marked that battery up that it doesn't have thermocoupling, so I'm always a bit wary with that battery not to overdo it because I don't want actually cells to catch fire. Now what we're gonna do with this one, I'm gonna take that thermocouple off, and the easiest way to do it is actually just snip it. So snip these two wires. There you go. Strip the ends, and then we're going to apply some solder, and I'll solder it on. I'll do it like that, so it goes, so you get one on each plate, or I actually can remove this section of the plate and go directly onto this terminal up there like that. That would probably be the bit better option. So little brass wire brush, just gonna clean this terminal. I mean, mind you, I just saw little sparks coming out. It's because battery cells are charged up, so there is power within the battery. So I'm gonna take this section out, just gonna clean it up. I think they use like a silver based solder that requires higher heat, so mine needs a bit higher heat as well. Just hold it a bit longer. Oh, actually I got an idea, something easier. Whoops. Leave that little bit of cable there, that little tail. bit of flux on it. Clean this section here as well, this plate. So a nice little dollop there on the plate. Now let's do the same thing on this wire tail here. There's a nice little dollop there as well. You can see it right there. Now we got our little thermocoupling. Bit of flux on both ends. So if I pick up right, that's a bit, that point is a bit dirty. Load it up. That's it. Both tails are loading up with the solder. And get back to our battery. Let's do one up there. Change its color, and then one down here. That's it. It's one thermocoupling done. Now the battery should show some sort of status. On the beginning it was showing 0. You can see the battery is actually it was actually fully charged. The only problem was it had a break on that thermocoupling. So this one is now safety BWBCP 85 Celsius. There you go. Borrowed from fake Makita. Right, put the cover back on. Then we will test the battery. One thing missing, a spring that popped off earlier. I think I will need to move this thermocoupling on the other side, perhaps there. Yes. Long screws for DeWalt. T10H. Extra light on. So far we got 2 DeWalt batteries sorted, and we found the fault on the fake Makita one, and I use it as a donor for a part. So fake Makita can repair DeWalt. Who would think about that? Brilliant. So 2 of them repaired. Let's go for the next one. So this one, it's all connected, it's all good, but I can see through here that these contactors are spread out. They just got worn out from use. I mean, this is 4-amp battery. I had this battery 6 years now. Must be 6, 7 maybe. Yeah, it was a long time ago. It was last time, and my van was broken into, and all my tools have been taken away. Very sad moment. Literally everything I had was gone. I had to replace everything. And a friend of mine had someone work in a tool shop, his uncle, and he sorted me a good deal to buying DeWalt. Before that I was actually mainly Makita guy, but try DeWalt. Yeah, it's all the same thing, does the job. Right. I hate when people steal tools. Right, you can see this is the thermocoupling in its original state. This battery looks different than the previous one. Previous one had some like a little circuit board there. Obviously the other one, the previous one we done is 5-amp, much younger generation battery. This is older battery, but pretty much all same apart from that circuit board that is not there. Now what I'm thinking of, yeah, you can see the damage on these contactors. So let me just check for the voltage. It's showing 1923, 1924, 25 volts. So battery is fully charged, but it's losing contact when I slide it into the tool. Sometimes works, sometimes doesn't. Let me just try to put it on like this. It's gonna go in. It does work now, but with the casing on, it wouldn't. Or a little jiggle and it stops working. My impact driver didn't work well. So let's see if I can put this new contactor plate on. That white stuff is some kind of glue on it. Really all I need is just this one section. Would it be possible to just replace one section? Or can I actually straighten this up a little bit? It's gone so soft. I think I actually can straighten it up. I think that's better. I just straighten it up now. It is quite worn out. Right, I think I'll be happy with that now. It's just straightened up, so yep, good. It works. I'll keep spare contactor plate for next time, because I do have quite a few of these, so every now and again they need repair. I don't like just chucking them away, as you can see. I like to get maximum out from them. I like to put them on the charger just to double check to see how it's charging, because charger will use these other points, other connections here. That's like TH for temperature, and then you go C1, 2, 3 and 4. It's measuring the status of individual cell blocks. Which obviously the tool itself does not do, but charger does, so I'll try to put that on a charger. Yep, it's charging. Stopped. Now I remembered, it didn't like charging either. I think I need to replace the contacts. You can see that little movement. No, little jiggle, and then it starts again, and that was doing same thing on my impact driver. So I will replace them contacts and be done with it. Opening. Now I will have to remove that adhesive or silicone, whatever they put around that contactor block. And there will be some wires that run to each battery cell block, so I need to identify them and solder them on in a correct order. Might be a bit tricky because I mean this new one I got, they're all color coded. In existing one they're all black. So we'll see. Heat up this terminal. There you go. One's out. I'll heat this side. See some smoke coming out. It's getting hot. Come on. It's connected with the wire. It's taking, the wire itself is taking quite a lot of heat. I just need to snip it off. Right, snip it off. So that's it. Negative and positive terminals. Entire block is moving. It's connected on the back with this glue. Kind of like a mastic or something. It's not silicone. You can see these wires, like that one, that one, that one and that one. They're just the bare wires. Also the replacement one, they're all color coded. So I want to just expose this connector down on the bottom, so we can trace them and identify them, which wire is going to go where. They don't make it easy with this. Whoops. obviously every now and again something shortens there. Not a big deal, I don't think. Lots of this gunk. Pull this off. It's almost like you need an extra pair of hands. So we got first, second, third and fourth, and that could be done in this order. So I could literally just unsolder them there, there, there and there. Just to check, is this going to be long enough? White one definitely, yellow one is a bit longer. Then we got the green one will go there and blue one back here. Yeah, so let's go for that. Grab the wire. Okay, let's clip it on the side. Let's do another one. It's another one. And one more. There you go, a little spider. She's free. Now obviously this battery, as it is, it's not good like that. So just gonna repair the solder points on there like that. They got quite distressed. We need to put a bit of solder on that black wire. So let's load some solder on. Right, it's nice and rich in there. Right, replacement one. So the button thingy will go there. Has it got contact? I think it's got a bit too much of contact. So what I could do, I could actually take this existing one and put the existing one back on. So that one will go in where the little prongs, because you got two little points here and there, and they should go into these two holes here. Yes, they're in. Right, before I do that, missed a step. I want these two cables brought forward between to these two gaps here. Okay, now we got our red and black. So first one here on this side would be our white one. A bit of flux on it. Tiny bit of solder, because it's a very small wire. That's it. And then goes into there. Bit of heat, little touch, and she's on. So I can feed the wire through this little groove that was designed for it. Then we got next one is yellow one. Just gonna sort out the end of the cable a little bit. Then a little bit of heat. Ta-da! That one's done. So feed that cable through the little cable groove out of the way. Then we have a green one. Green one goes there, and that's the another one. And the last one, bit of flux, load some solder, done. So I got 4 of these little ones done. Now let's connect our positive terminal. That's positive terminal done. Now we have, ouch, it's a bit hot. Now we need to connect this one here. So negative terminal. So I'm just going to shorten this wire here. Put a bit of flux. Load up some solder on the wire. Now, before I actually get them together, I'll put a bit of sleeving over it. So I just right, this is a bit of heat shrink sleeving. Don't need that much. I'll just do about half. A bit less than that. Trying to push the sleeve over the lumpy joint. It's happening, it's happening. It's coming on. Bit of heat. So it shrinks up nice and tight. There you go. Right, so should be all connected. I'm going to now take the old one. The old one fitted really nicely in. And it's not broken. A new one sort of doesn't fit properly, so a bit of flux, bit of solder, slide that in, back into position. Now we got these two connectors to do. So we got red one and we got black one. bit of solder to both sides. Yep. Right, now all the contacts are connected. If I put this back together, then we'll try it in the charger again with new contacts. That's basically how to replace the contacts. I'll have to put some sealant around that connection if everything is fine. I think I need to move this black wire slightly out of the way. Get the blue one off. Yep, bit of jiggery pokery. Right, there's the charger gone. Right. It's showing this fully charged, which obviously isn't. So let's just double check all the connections. Oops. Aha, culprit. The negative terminal has come off. Couldn't see it behind that sleeve. So what I'm going to do, I'm going to adjust the length of this wire so I don't have to bend it like that. It's quite a thick insulation on this. of repair, redneck style, eh? Bit of cooling. Right. Yeah, it's connected. It will work. I'll get it to work eventually. Still charging, it's not stopping charge. I think we might got it. Another screw. Yep, still charging. That's another battery saved. What was that, 15-20 minutes? Playing about. Well, 4-amp battery, was that about 50 quid? 50 quid in 15 minutes. Let's check the maths. £200 an hour. Whoa. I like that. Double check. It's showing already little rise. Right. Let's charge it fully. So that one is charging. This one is charging. That's the one we replaced the top on it. And this is one we replaced thermocoupling. That one is fully charged. So we managed to get 3 batteries done. We partially used one of the kits, like a housing kits. We don't need all these other bits. I'll keep some of these bits as a spare. And we salvaged out of Makita battery, thermocoupling, and gonna keep rest of it for spares. I mean, I will look into getting replacement cells and then just get another thermocoupler to replace that on Makita one. And out of 4 broken batteries, I got 3 batteries that are repaired. I think that is success in my books. I'm pleased. Thank you guys for watching, and if you like it, please subscribe, comment below. If you think it's a bit of too much of redneck style, say that. If you think it's best way of doing it, say that. You know, everyone has got different way of doing things. This is my way. I don't want to spend too much time on it, too much effort. If I can get it done on this way, I'll get it done an outer way and back in a hard work, hard use, because these batteries are actually making me money. They're not here for parade. They are to make me money. So all the best, guys, and see you again.